Okay, we're going to start off by having a look at some parabolic motion that's a little bit unusual. This event takes place at the Norwich Show in England every summer, and this absolutely crazy man puts himself inside a cannon and whoosh, pretty much a parabolic motion, but let's see how accurately it is. Okay, so we'll start from scratch with a new page, and we'll do a right click and insert an image, and double click on that, and there it is. We'll just make it a bit bigger. Now the various possibilities here, double click and change the transparency so we can see through, that's okay. I won't do that, is to do equal aspect just to get the real space going. Alright, now you can either think of this as a symmetrical parabola from both sides, and that would be quite a good exercise to do if we just put the cannon up to this level here. And let's have a look at an alternative one, which is to take this point here and move it to the origin. Okay. So now we're going to move it all down here and fit a suitable parabola to this. Now it'll be an upside down sad parabola, and it'll have x equals 0 and y is 0, and when x is something else. So we need to put an equation in, so I'm going to enter an equation, and let's decide on the form after some discussion. It's going to be ax to give it some height, and it's going to be b minus x on the inside. So that's certainly going to be a function that when x is b you've got a 0, when x is 0 you have a 0, and a will be needed to give it some height. Now the way autograph works, whenever you have constants, the constants start off with the value of 1. So if I press OK, first of all you'll notice that it's crawling along here, which is absolutely perfect because look, I've got the slow plot on. You do not want it to suddenly, there it is, and then you haven't had a chance to discuss where it's going to go. So we've stopped it here, and you can start asking questions like, is it going to appear from down here, or is it going to appear from up here? And obviously we want it to be this sort of shape, so hopefully we've got this the right way around. The x squared term is negative, so yes. I think if a and b are both 1, then it's going to go through the origin, and then it's also going to go through here, and it's going to be upside down like that. So let's see. Let's take the brakes off now and have a look and see if it does indeed confirm what we expect. Yes, that's fine, and it's pretty much doing as we expect. It's going to go through here and through there. I didn't quite get the scaling right, but never mind, we've got the principle right. Okay, just for you fast forward, now I'm going to select nothing to deselect the image, and edit, select all the scribbles, and delete. Alright, so the next thing clearly is to start fiddling around with the constants. So at this point I think I'll select that and display the equation, just the black bit we can delete, and I'm going to show the detailed object. So I got the values of the constants. Perfect. Alright, so we'll just park that up there so we can see what's going on. And so now I want to deselect that and open up the constant controller. Now the constant controller in Autograph is a little bit different to most programs which have slider bars, because this allows you to change the value of the constant and also the value of the step by which the constant changes. So let's increase a first of all and see what happens, but I think much better to see if we can predict what happens if you increase a. So if a goes from 1 say to 2, which will happen now because I've changed the step to 1, if I press this button a will become 2. Well, I think the first thing to realize is that these 2 points are going nowhere, and that this will go up. Let's see if that does indeed happen. Ready, steady, go. Yes, perfect, just what we wanted. However, I think it would be a good idea, it's going to go far too high. We could try to get it right, but I think b is the next one to change. So let's change b. Now what's going to happen to b? Well, b is the value of x where this function hits the x-axis, so if I increase b it's going to move to the right. Okay, let's see if that does indeed happen. So 1, whoops, let's go up in steps of 1, would be much better. So yes, that changes to there, but of course a is going through the roof. But we'll just take it to roughly where it lives, which we're not sure, but it looks like round about there. So let's go back to a again and reduce a in steps of 1, and we shall get down to a value which will work quite nicely pretty soon. But somewhere between 0 and 1, so this is where reducing the step dynamically is so useful. So I'm now going to bring it down in points, 1s, and then reduce it again and bring it up again, and there we have a pretty good fit. I think possibly we could increase B just a tad in steps of 0.1. That's pretty good. So there we have it. If you ever want to take this up as a sport, just bear in mind that A, it's pretty dangerous, but B, you will be travelling as a parabola for most of the time. It looks like towards the end, if you don't want to land on your head, you do a bit of gymnastics to try and put things right, but otherwise you are definitely travelling in parabolic motion.